Our next great discovery is the story of Joseph Thomson and the electron.
Here we are.
So everything that we can see is made of chemicals.
That's right.
What's the future?
And they're all bonded through electron interactions.
Thank goodness.
The future.
To find out about it, I paid a visit to Harvard University. Dudley Hirschbach is a professor here and winner of the 1986 Nobel Prize in Chemistry for his research into the dynamics of chemical elementary processes. So, Thomson didn't discover the electron.
Well, it's of course said that way, but he didn't discover in the sense that he said, Eureka, I've got this thing, here it is. He did an experiment that allowed him to measure the ratio of the charge, the electric charge, to the mass. And then later he was able to get a rough measurement of the charge and therefore show that the mass was very, very small. It was about 1/2000th of the mass of the lightest known atom, hydrogen atom. So it showed that he could extract in the experiment a very small piece of an atom. Well, that was a tremendous shock. People didn't imagine. Yes, yes. Electrical piece of an atom. It was a very small part of the atom.
At the time of his discovery, Thomson was a professor at England's University of Cambridge. He was using a device called a Crookes tube in his experiments.
I happen to have here a little apparatus that's akin to the one that J.J. Thomson used in 1897. It's called a cathode ray tube, just an evacuated little glass cylinder with some electrodes. And we can hook this up and show the key points of his experiment.
A replica of the first CRT.
Yeah. It's the first cathode ray tube. It's ancestor of the television tube, as a matter of fact. You do the last one, and we should get a stream of cathode rays or electrons going there, and it'll show up. A few of them bang into this phosphor-coated piece of cardboard there. Here, I'll give you a magnetic field you can use to deflect the electrons.
When Thomson exposed the stream of cathode rays to a magnet, the stream would bend. Since magnets can only affect matter, this meant the stream of rays was composed of some kind of electrically charged substance called radiant matter. After many hours of observing and measuring, Thomson realized he'd found the first subatomic particles. The ray was a stream of electrons. It was a revolutionary discovery.
Some years later, a student of Thomson, Ernest Rutherford, was able to show that the positive charge in atoms, which of course had to be there to balance the negative charges of this little electron sort of scooting around, was localized in a tiny, tiny nucleus, 100,000 times smaller than the size of the atom. And so almost all the mass was, of course, in that nucleus as well, because electrons are so light.